This tutorial, I'm going to go over exam number 12. Not everyone got 100 in this test. However, one student finished the test in 20 minutes and he got pretty close to 100. So let's go over the test. I'm making promise next week when you take the test. Next Friday, I'm going to give you the same test. Except I'm going to add one more problem, ballistic pendulum we did yesterday. Okay, so 13th problem going to come from the test number 12, and one problem going to come from ballistic pendulum homework. So if you do go over this test 12 at home and ballistic pendulum homework on the weekend, you should get 100. If you don't get 100 at home, you're not going to get 100 in the classroom. Please practice. Okay, let's go over problem number 1. So problem number 1 is you have Hooke's law. So I gave you a spring, and then mass, I gave you a very friendly number, 1 kilogram, and delta x is 0.1 meter, and then I gave you k is 100 Newton per meter. Now if I give you this, if you stress it, right, this is right here, fs is equal to 0, right? However, if you stress it, you stress how much? You stress 0.1 meter. So the velocity is 0 over here. So over here, loss of potential energy due to spring, and 0 kinetic energy. And over here, 100% kinetic energy, 100% kinetic energy. So let's put 100% kinetic energy. So kinetic energy at location 1 is equal to potential energy at location 2. So kinetic energy at location 1 is equal to potential energy at location 2. So what is potential energy or kinetic energy? Kinetic energy is half mv squared is equal to half kx squared. Now we're trying to find the velocity at f, velocity when fs is equal to 0, when it is in equilibrium. So half cancel, so v squared is equal to kx squared over m, right? So v squared is equal to k is 100, 0.1 squared over 1. So v squared is equal to 100 times 0.01 over 1. So 100 times 0.01 over 1 is just 1. V squared is 1, so v is just 1. So this is the problem number 1. Problem number 2 is similar, but problem number 2 has friction. Here is no friction, but problem number 2 has a friction. So let's go over problem number 2 here on this side. So problem number 2 is similar. You have 1 kilogram, right? You stress it. Again, everything is K is 100 Newton per meter. And then you stress it how long? Point delta x is 0.1 meter. Okay, so now scenario 1 and scenario 2. Okay, and there is a mu k, of course, 0.3. Now scenario 1 and scenario 2 is the same thing, just like before. Loss of kinetic energy over here, kinetic energy at location 1 is equal to potential energy at location 2, right? No, absolutely not, because there is a friction. Now I cannot stress that enough. So the velocity is not going to be 1, velocity is going to be less than 1, because the friction is not a conservative force. Okay, now what are you going to first do? You're going to first find, yeah, here you have loss of potential energy, 100% potential energy. Let's find those potential energy. Pe is equal to half kx squared, right? So Pe is equal to half, k is 100, and x is 0.1 squared. So Pe is equal to half 100 times 0.01. So Pe is equal to half, this is 1. So Pe is equal to 0.5. Great. Now, let's find work done by friction. Work done by friction is, of course, FFD. Now, you can write also FFX. FFX. Okay, so what is FF? Let's do FF over here. So FF is, let's do FF over here. We don't need that. So FF is, of course, mu k mg. So FF is equal to 0.3, m is 10, m is what, 1, and this is 10. So this is this is just 3. So FF is just 3. Okay, so 3, so WF is equal to 3 times 0.1. So WF is equal to 0.3. Okay, now we're going to finally write uh, work done. What do you try to find? Kinetic energy is equal to potential energy minus work done by friction. So kinetic energy is equal to 0.05 minus 0.03. So kinetic energy is uh, 0.2. So what is kinetic energy? Kinetic energy is, as you said, 0.2. So half mv squared is equal to 0.4. Well, half mv squared is 0.2. So mv squared is 0.4, right? V squared is 0.4 divided by 1. So v squared is 0.4. So v is the square root of 0.4. When you square root decimal, it gets bigger. All right, so this is the answer for problem number 2. Okay, so problem is like this, right? All right, and there is this. Okay, so you have, of course, one kilogram, and K is 10,000. Why 10,000? Because I wanted to give you a nice number, so you don't have to deal with the decimal. So you stress it. You stress it. You stress it how much? You stress it 0.1. Okay, and now what you want to find is the distance d. All right, look at the distance d, and this is h and this is d, so you're going to find the distance d. Know that velocity over here is 0, no friction, no friction. Okay, so what do you know over here? Location 1, at location 1 you have loss of potential energy, right? 100% potential energy, because uh, you stress it. Scenario, we're going to call scenario 1. You stress it, loss of potential energy. We're going to call scenario 2. Right. So scenario 1, you have loss of potential energy due to spring, of course, because you stress it. Scenario 2, you don't have kinetic energy because velocity is 0 over here. However, over here there is a height, so you have what do you call gravitational potential energy. So spring potential energy and gravitational potential energy, they are two are in action. So the spring potential energy is, of course, half kx squared, and gravitational potential energy is mgh. Be careful with the h, is because, so, right, you don't want to write h, you want to write h with respect to the d. Okay, you want to replace h by d. How? By using sine theta is equal to opposite, which is h, and hypotenuse, which is d. Now what is d? D is h over sine 30. Okay, right? So now, right? Okay, let's see. Mgh. Now you want to replace h. All right, h. So h is what? H is d sine 30. Yeah, h is d sine 30. So half kx squared is equal to mg d sine 30. Okay, excellent. So kx squared is 2mg d sine 30. What we are trying to find is d. So isolate d. D is equal to what? Kx squared over 2mg sine 30. How can it be easier than this? K is 10,000 times 0.1 squared. 2 is 2, m is 1, g is 10, sine 30 is 0.5. Okay, so now what do you have? D is equal to 10,000 times 0.101, and here you have um, 0.5. This is 0.5. Why this is? Because this is a half. So it's 5 times to 10. Um, so D is equal to here, cancel, so 100 over 10, 10. So D is equal to 10. So you did not have to use the calculator for this problem, because I choose the number in a way that doesn't just really doesn't force you to use calculator. Go to number 4, and number 4 is an elastic collision. Why? When you collide and stick together, that's an elastic collision. You saw it yesterday, and you saw it a lot of times. So number 4. there are a car, two identical car, one identical car which is 10,000 kilogram, and another identical car. This is before, also 10,000 kilogram, right? This is before. After the collision, they both stick together, right? So and this one velocity is zero at rest. However, this one velocity is 24 meter per second. Now this one hit that one, right? As a result, they both stick together. That's after the collision. So again, momentum before is equal to momentum after. Why momentum conserved is because no car toss it in the air or jump up. Okay, no car jump up, so they remain on the ground, so h remains zero, so conservation of momentum. So m1 v1 plus m2 v2 is equal to, now at right here you have only one v, right? So you write only one v, m1 plus m2. Here this is zero. Why? Because this car at rest, this car was at rest, this car hit this one. Okay, so m1 is 10,000, v1 is 24, and this is v, where you try to find 10,000 plus 10,000. So now this is 24, 1 2 3 4 is equal to 20,000 v. So 4040 cancel, so v is equal to 12 meter per second. So cannot be easier than that. Very easy problem. Now let's go problem number 5. Problem number 5 is directly come from exam number 11. Why is that? Because exam 11 I gave you 30, height is 30, and angle is also 30, and mass is also 100. And I ask you work done by gravity, right? That's what I asked you. Now I'm going to ask you work done by net force, right? Work done by net force or network. Given the fact that I'm going to just introduce you, mu k is 0.1. The other one, exam 10, exam 11 was frictionless. This is with friction. So what are you going to do? You first find the potential energy at location 1. Potential energy at location 1 is mgh. So potential energy at location 1 is m is how much? M is 100, g is 9.8, h is 30. So potential energy at location 1 is equal to 29,400 joule, right? Now, this is not answered. I did not ask you work done by gravity. What I asked, work done the network, okay? Work done by net force. Okay, so the network, so we have to find the WF. What is WF? WF is FFD. So let's find FF. So what is FF? FF is mu Fn. So what is Fn? Mg cosine theta. So mu is 0.1, m is 100, g is 9 point, or just 10. Cosine theta is 30. Okay, so FF is 87. So WF is equal to 87 times D. D is, we're going to find D. What is D? So, what is so? Sine theta is equal to opposite, which is height, hypotenuse, which is D. So, what is D? D is h over sine theta. H is how much? 30. Sine theta is half. So, 60. I cannot write half. 60. So WF is equal to 87 times 60. So 87 times 60, 5220. 5220. All right. So now we are finally find network is work net is equal to potential energy minus work done by friction. So potential 29400 minus 5220. So 29400 minus 5220, and that is 24100 joule. So you're going to find the one that is very close to 24100, yeah, 24,100 joule. Okay, so that was problem number 5. So number 6 has to do with granite. Number 6 has to do with granite. 20 kilogram granite, you throw it 20 meter per second. So px is 0, py is 400. Okay, kilogram meter per second, if you like to write it down. Now, you throw it out, and your purpose was it break into two pieces uh, to get to the target. One target was 10 kilogram, 10 meter per second. The other target was 10 kilogram, all right, and x direction. You're going to find out whose direction it is, and of course the resultant, and that's most important. Now let's do x and let's do y. So p before is equal to p after, momentum before is equal to momentum after. Uh, p before is 0, right, and the x direction is equal to m1 v1 x plus m2 v2 x. So m1 is 10, v1 x is 10, plus m2 is 10, v2 x. As you see, v2 x is a negative. Okay, now this one is of course 400 is equal to m1 v1y plus m2 v2y. Now this one is 0. Why is that? Is because is this one moving to y direction? No. So 400 is equal to m2, which is 10 v2y. So v2y is exactly 40. Now if you take uh, the 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 Pythagorean theorems to find the resultant is 41. Now which direction is going to? So theta is equal to tangent inverse y. Which one is y? 40 is y. X negative 10. So tangent minus 1 is negative 4. I think that's 76-degree velocity. So meter per second, and this is negative 76. All right. Number 7. What is number 7? Okay, so I gave you a rover. So I made it clear. I gave you a rover. So there is a rover. Make sure you know that rover. And however, I did not tell you the surface. So rover on X. So that's for sure. Rover on X. X I did not give you. So I gave you velocity. Velocity is 11 meter per second. I gave you final velocity. Final velocity is 0. I gave you uh, the, the, the distance from velocity, initial velocity to final velocity is 9.1 meters. Okay, I gave you almost everything, right? I wanted you to find what type of surface, what is X, okay? What is X? So there is no ambiguity over here. What is X? So you know that the work done by friction is equal to change in kinetic energy. Work done by friction is of course FFD is equal to half mv squared. So FF, what is FF? Let's do FF over here. FF is equal to mu k mg, right? So you're gonna write mu k mgd. Don't forget d is half mv squared. Now as you see, cancel. Now 2 mu k gd is equal to v squared. Now mu k is equal to v squared over 2 gd. What is V? V is 11 squared, and 2G 9.8, 9.1, and that is give you 0.68. And 0.68 is, okay, rover. Okay, now you're going to take a look at the reference table. The first one, rover, okay, rover on concrete, okay, rover on concrete. So first one has to be rover, so you have only few options. Okay, rover on asphalt is 0.67 and rover on concrete is 0.68. So uh, I asked you to round it to two decimal place, right? And of course they use the sig fig to do this one. So if you rounded it to two decimal, then only one option is rover on concrete dry. Rover on concrete and dry. Okay, that was problem 7. Problem 8, we did it like many times, but still everybody got it wrong. And unless and until I see everyone get it right, you're going to keep getting this problem. All right, so please pay attention. Josh is 40 kilogram, right? Josh jumping height is 0.8. Josh crouch height is 0.2. Acceleration due to gravity is negative 10. Now, this is location 1. This is location 2. This is location 3. This is location 4. At location 1, there is Earth and there is Josh. The earth is moving down. Who is doing fast? Josh is jumping up fast, and then earth is moving down. So this is earth and this is Josh. Now, with this understanding, we're going to complete this table. So what is the table we're going to complete? We're going to complete this table. So this is location 1, 2, and 3. And this is velocity, this is time, this is acceleration, uh, this is net force, this is Josh, and this is earth. Location 1 and location 4. So this is for Josh. So for earth, let's use blue. So for velocity, acceleration, time, and net. Okay. Okay, we don't need so many boxes. This is space we need to complete this table. So this is 0. Why? At location 1, at location 1, everything is 0, right? 0. Okay, all right. Okay, make sure you understand what's going on. Now, velocity of Josh at location 2, because he crouches. So to crouch, to jump up, he needs some velocity, and velocity, what? Vf squared is equal to Vf squared is equal to Vi squared plus 2ad. Now right, V3 squared is equal to V2 squared plus 2ad. This is 0 and this is V2 squared. You try to find it. This is acceleration due to gravity, which is negative 10, and this is 0.8. So velocity at location 2 is 4. So you're going to write 4. Now you're going to find acceleration at location 2. Vf squared is equal to Vi squared plus 2ad. And this is, of course, V3 squared. This is acceleration at v2 squared is equal to v1 squared plus 2ad. v2 is 4 squared, v1 is 0 plus 2. Acceleration you try to find, he crouches only 0.2, so acceleration is 40. So you're going to update it. Now you're going to find the acceleration is 40. So now you're going to find the time. Vf is equal to vi plus 80. What is Vf? At location 2, remember, at location 2, to find the location 2, you're going to use location 2 here. Location 1 plus 80. Location 2, what is this velocity? 4. Location 1, what is this velocity? 0. Times, we know the acceleration 40t, so t is 0.1, so we're going to write 0.1. If this one is 0.1, if he accelerated 0.1, the earth also accelerated 0.1, so we're going to we get that one right. Okay, good. Now we're going to find the find over here velocity. What is the velocity over here? Velocity over here is 0. What is the time over here? Vf is equal to Vi plus 80. What is Vf? Location 3. Vf is location 3. What is Vi? Location 2 plus 80. Location 3 velocity is 0. Location 2 velocity is, of course, 4 plus A is 2 to 3 is gravity, because you're in free fall, so 10t, negative 10t. And so t is 0.4. So t is 0.4. Acceleration. What is the acceleration over here? Is negative 10. Acceleration is negative 10. Okay, great. Now we're gonna find net force. We're gonna find this one. Okay, now let's find this one. This one is in the test. There is a typo. This one should be F is equal to ma, which is mg. Only one force acting at location 3, which is 40 times negative 10. So negative 400 Newton. So this should be negative 400 Newton. Okay. So now, so let's find this one. Momentum before is equal to momentum after. M1 V1 plus M2 V2 is equal to M1 V1 plus M2 V2, right? So this is 0, this is 0, so 0 plus 0, and this is 40 times V1 is 4 plus 6 times 10 raised to 24. Velocity of the earth recoil. Velocity of the earth recoil is 160 divided by 6 times 10 raised to negative 24. So now 160 divided by 6 is 160 divided by 6 is 26.7. So 26.7 26.67 times 10 raised to negative 24. So 2.667 times 10 raised to negative 24. So this is 2.667 times 10 raised to negative 23. negative 23. Okay, so keep that in mind. Now we're going to find the velocity of acceleration of the earth. Vf is equal to Vi plus At. So Vf is equal to V at location 4 is equal to V at location 1 At. V at location 4 is this one. So this one is square is this one is what velocity at right here is 2.667 times 10 raised to negative 24. This is 0 plus acceleration we're trying to find times. Okay, now acceleration is 2.667 divided by 0.1 times 10 raised to negative 24. and this divided by 0.1 would give you 2 6 26.67 times 10 raised to, why I did put negative 24, this is negative 23, I must be tired, 23, so negative 23, so this must be 2.667 times 10 raised to negative 22. So this one acceleration is 2.667 times 10 raised to negative 22. Okay, great. You can write 3 times 10 raised to negative 23, 3 times 10 raised to negative 22. You can do that, but F is equal to ma. F is equal to ma. This is for Josh. This is for Earth. For Josh, m is 40. This is 40. So for Josh, the net force is 1600. For Earth, the mass of the Earth 6 times 10 raised to 24. The acceleration of the Earth 2.667 times 10 raised to negative 22. Okay, so 6 times 2.667 is 16 times 10 raised to 2. So 1600. Okay, very nice. To both of the nice. So now you are held responsible for, so this is 1600. This is negative 1600. Okay, so you are held responsible for the Newton's second law. Newton's second law. So this is Josh. This is F. G is equal to mg is equal to 40 times 10, which is 400. This is F push is equal to mg plus a, and which is m is mg plus a. M is 40, G is 10, S is 40, so 40 times 50, 2000. Okay, good. So net force is 2000 minus 400, so 1600 Newton, and that's check. Now Earth is Fg is equal to G m1 m2 over R square. Okay, so G is 6.67 times 10 raised to negative 11. M1 is 40. M2 is 6 times 10 raised to 24. And the distance is 6, 3, 7, 1, 2, 3. Let me see. With 6.37 times 10 raised to 6. 6.37 times 10 raised to 6 is square, right? So you have 6.67 times 40 times 6 divided by 6.37 square times 10 raised to negative 11 positive 24 minus 12, and that gives you, of course, 2000. No, that gives you 400. 400 Newton. So this is 400 Newton. We can call it FG prime. So now we're going to do this one. Mg plus. All right, so Fg is equal to 2000 Newton. So F net is that. Okay, now let's do Newton's third law. Newton's third law. So Newton's third law, you have the Earth and you have the Josh. Not right. You have the Josh. Okay, so now let's Earth and let's do Josh. So now let's write for Fg. and this is fg, y big fg prime, and this is a push, and this is a push prime. Now you remember fg um, a push prime. So now a push prime minus fg is equal to 1600. Let's see how that looks. A push prime minus fg is equal to 1600. Let's put them here. You should understand this thing. This is very nice. Okay, now that's for Josh. That's for Josh. For art, let's see for art. You have fg minus f push is equal to negative 1600. How? Okay, fg which is positive, f push which is negative is equal to negative 1600. Okay, you put your finger here, and this is 40 centimeter, so you're going to try to find your reaction time. D is equal to half at squared. 40 centimeter is 0.4 m5 t squared. So t is equal to I don't know, 0.3. Let's take the calculator. Yeah, 0.3. Okay, so with that you should be able to find everything. So this is location A, this is location B, this is location C, this is location D. Here you see a Mr. Bari walks, who is 50 meters away from A. At B, you eventually hit the brake with 8 meters per second squared. Over here, your velocity is 30. Over here, your velocity is 0. And that's basically it. And I want you to find out whether you can stop the car over here, then you can save Mr. Bari. If you cannot stop the car over here, you cannot. If the car past 3, then no hope for this. Okay, now from A to A to C, we know 55, but we have to find A to B. Why? Because that's car moving with constant velocity. D is equal to Vt. So D is equal to 30 times 0.3. So D is equal to 9 meters. Okay. So A to B is 9 meters. Okay. Right. So now we want to find from B to D. Okay. So P to D is Vf squared is equal to Vi squared plus 280. So this is 0 squared is equal to Vi squared, which is 30 squared, plus 2 times negative 8 D. So D is, you have 900 divided by 16. 900 divided by 16, 900 divided by 6, 900 divided by 16 would be 56. So D is 56. 56 plus 10 is 66, but 56 plus, oh no, 9, 65. So no, you did not stop the car. From A to C is 50, but you stop the car at D, which is 65 meters from A. So let's do problem number 10. You did it before. 10 kilogram, you pull it, some force, let's say 45 Newton at 30 degree, move 3 meter, and 0.4, which is kinetic friction. You want to find the work done by net. All right, so FA has two components, FAX, which is 45, cosine 30, which is 39, FAY 45 sine 30, which is 23. So now if you do the free body diagram, 10 times 9.8, 98 Newton, this is FA is 39, this is FAY is 23, so 98 minus 23, so this is 5, and this is 775 Newton, which is Fn, and this is Ff. Ff is 0.4 times 75, and that is 0.4 times 75, and that is 30. Wow, that's not a bad number. Don't expect that. Okay, so 30. So then net is 39 minus 30, so which is 9. So then work done by net is F net D. So here is 9, and D is 3. So 27 joule. Okay. So of course I did some. This is probably 22.5. So I compromises with decimals. You have T, you have D, still making mistake. 2 seconds, you move 2 meter. All right. And the remaining next 1 second you move, you are at rest. Next 1 second you move 2 meter. Next 1 second, you move. Next 1 second you move 1 meter. All right, so that's it. Now, if you do a VT, and then what are you gonna get? Velocity for first 2 seconds is 2 over 2 is 1. So 1. First 2 seconds your velocity is 1. So your velocity is 1. Next 1 second your velocity is 0. Next 1 second your velocity is, first you're gonna have to find displacement for minus 2, which is 2 is equal to half bh. All right, and that is, this is 2, this is 3, this is 4, this is 5. 4 minus 3, which is 1. So your velocity is a 4. So 3 comma 4. At 5 seconds, your velocity is negative 4. Okay, good. Now your x1, y1, x2, y2. y2 minus y1, x2 minus x1, right? y2 is negative 4, y1 is 5 minus 3, which is negative 8 over 2, which is negative 4. Acceleration is negative 4. Okay, now y is equal to mx plus b, right? 4 is equal to minus 4, x is equal to 3 plus b, right? 16 is b. Now you want to find v of t is equal to at plus vi. At is negative 4t, negative 4t plus 16. Now at what location you know velocity for sure? What? At first second velocity is 0. If you put 4 over here, it give you negative 4 times 4 plus 16. Velocity is 0. That means this is a good equation. Now you want to plug in and the number that I give you, and that is 4.8. So if you do 4.8, that gives you negative 3.2. So power is MAV. M is 10, negative 4. Power is 128 watts. So problem number 12, we're going to try to find the work done by applied force. Okay. This is 12 kilogram. This is F of F is 10 Newton. This is moving 3 meter per second square. This direction. This is 4 meter. Applied force. Work done by applied force. Okay, right. So now, first thing first, F is equal to MA. You have FA minus FF is equal to M12 times 3. FA is, we are trying to find, this is 10, is equal to 36. So FA is 46. Great. All right. So work done by applied force is FD. What type of F? A. FA. FA is 46. And this is 4. 46 times 4. 184. Sure. Okay, great. That was problem 12. Now let's go over 13. Problem 13. I'm gonna have to take a look. Problem 13. This is 10 meter, and this is what? 20 degree 37 meter. 20 degree 37 meters. Okay, all right, that's it. That's all you need. um, so now you have to draw a parallelogram, so you put it over here. uh, Try again. Try again. Okay, so this is 70, so this is 70, this is 110, this is 110. All right, so resultant. So million times I told you, if you use this one, r square a square plus b square plus 2ab cosine theta, you're still getting it wrong. This is 10 square plus 37 square plus 2 times 10 times 37. This is 110 45 meter. Now, if you do r square is equal to a square plus b square minus 2ab cosine theta, law of cosine, then you have to use 10 square, you have to use 70 because head and tail, head and tail. Law of cosine uses head and tail. 10 square plus 37 square minus 2, 10, 37 cosine 70, and that's also give you 35. First thing you're going to do, you're going to make this one longer, vector a and vector b. So let's make the vector b longer and make the vector a longer. Let me see where is my glass at. Okay, so now go to 0 comma 0 of the, do it again this way. The x-axis of the protractor has to be sitting on angle, the x-axis of 0 degree sitting on vector b. Okay, so now if you read this one very carefully, you're going to see this is 40, this is 50, and in the middle there should be 45, and then 46, 47, 48, 49. I believe this is 48 or 49, but if you do it carefully, yeah, 48. This is x-axis, this is y-axis, this one is um, vector a, and this one is vector b, and this is 10, this is 8. And we're going to draw the parallelogram. Before parallelogram, we measure this one is 40. From vector b to vector a is 48. Now, if we do parallelogram, let's not do parallelogram. We just I'm going to just finish it. R square is equal to a square plus b square plus 2ab cosine theta. I already have the angle between vector. Why I need the parallelogram for? Okay, a square is 10 square plus 80 square plus 2, 10, 8 cosine 40 is 16 Newton. Okay. So I'm going to give you this test again on Friday. Please make sure you get 100. You will not get 100 unless you study at home. I'm going to make an assignment, call assignment 64. I'm going to give you this problem, 14 problem. Out of 14 problem, you're going to solve only 10 problems. Show all work to get 100. But that's not the main objective. Main objective is to get 100 in exam number 13. See you Monday.